Now, in the first two sections of Chapter 11, we were interested in the difference in population means for two samples, be they dependent, i.e. matched pairs, which was Section 11.1, and then an independent, which is Section 11.2. Now, in 11.3, we're going to be testing the difference between two proportions. This is kind of a big deal because this is how surveys work when they poll people, right? In general, they want to know the difference in, for example, I don't know, the group of Democrats and the group of Republicans, what percentage of them approve of this measure or that measure, that kind of thing. All right. And there's this lovely test statistic for it. Isn't that great? Hey, look, 6 steps, just like before. Now, notice this is a little bit different. This is like it was for proportions back in Chapter 10, namely that you need n times p times 1 minus p to be greater than 10, but for each of the proportions. You also need each sample size to be less than 5% of the population size. This part ensures normality. We learned that in Chapter 6. This part ensures independence, which we also learned in Chapter 6 we need, because basically we're trying to ensure that things sort of follow a binomial distribution, and therefore they will follow a normal distribution as long as n times p times 1 minus p is greater than 10. Okay? And of course you have to do random, unbiased sampling, that kind of thing. All right, so we have our lovely hypotheses. Sorry, my brain is freezing there. And notice, just like in the last section, you could write this two ways. You could say P1 is equal to P2, or you could say P1 minus P2 is equal to 0. Either way is completely okay. Then we have this lovely test statistic, and P hat is given as that. Isn't that gorgeous? We'll have to figure that out. And then we've got our classical and p-value methods, just like usual, etc., etc. Okay, so is there a link between television violence and aggressive behavior by those who watch a lot of TV? Various studies have indicated or investigated this premise. A study considered if greater levels of TV watching by teenagers were associated with greater likelihood of committing aggressive acts over the years. The researchers sampled 707 families in 2 counties in northern New York State and made follow-up observations over 17 years. The table shows results about whether or not a sampled teenager later conducted an aggressive act against another person, according to a self-report by that person or his or her mother. So there we are. Aggressive acts, right? Were they watching TV less than an hour a day or at least an hour a day, which means an hour a day or more. Okay. And test whether there's a significant difference in the aggression levels between those who watched a lot of TV and those who did not. Cool. All right, so we are going to have to run a big old hypothesis test. For starters, we're going to need an alternative hypothesis, since they're just talking about being a significant difference, but they're not detecting which way they want to go. We're just going to say P1 is equal to P2, P1 is not equal to P2, right? And you could say, we want to know this is aggression level between those who watched a lot of TV and those who didn't. So you could say, for example, this is a lot, and this is little TV, right? Just to kind of keep track of what you're doing. So which group is which? All right, so we're going to have the lot of TV group and the little TV group. All right, step 2. Alpha. Hey, they didn't give it to us again. So I'm just going to assume that alpha is the classic 0.05 because that's pretty common. All right, step 3. All right, there's alpha, sorry. Now this Z0 statistic is going to be a pain. So let's start off with a couple things. We need to know what P1 hat, P2 hat, and we're going to need this P hat thing. So let's go find it. So I've already found P1 hat. I did that by taking the yes divided by the total, right, for the little people. And then for a lot of television people, it was 154 divided by 169. And then we're going to need that P hat. Oopsie. Oh, my goodness. Hold on. There we go. And then we need P hat, which is equal to X1, close parentheses. Oops, there it is. X1 plus X2. So this cell plus this cell, close parentheses, divided by parentheses, this cell plus this cell. There we go. Now I've got P hat. All right, we'll have to pick up back here for the next pit to find that test statistic.